Okay, now we're going to talk about the tough part, the tough case, side angle, okay? So this is when you have, so here's all the situations that you can have if you have side angle, okay? You can have actually not a triangle, okay? It can just not work at all. You can have a right triangle. You can have two triangles, or you can have one triangle. Okay, so we're going to go through examples to see what all of these look like. All right, so what if we have, they give us this triangle and they ask us to solve it. Solve it for the missing side, this side here, and find the missing angle measurements to the nearest tenth. All right, so here's the situation. Side, angle, right? We have two sides and the angle not in between them, okay? All right, so but we do have a ratio. We have an angle and a side across from it. And here we have a side, and we could find that angle. So let's use the law of sines. Let's say sine of 35 divided by 6 equals sine of beta divided by 8, right? This ratio equals that ratio. Okay, cool. So let's put this in our calculator. And we get, let's see, 8 times sine of 35 divided by 6. So I get that sine of beta equals like 0.765, something like that. Okay, so I can find beta. I'll just use the inverse sine of this, and I get that beta equals 49.89. All right. You guys have done something like this before when we were solving trig equations. Is there another possible value for beta? Remember, so here's our sine graph. This gives us that answer for inverse sine. We still need to find this answer. And what's that answer? So just like when we were solving trig equations, it is 180 minus this. Is there other possible? So let's call this beta 1, and let's call this beta 2. Those are the two possible angles here. Okay. Are they both actually possible? Well, let's think so this angle is 35 degrees. So if that was the case, so I'm going to draw two triangles. 8, 6, 35. So these obviously are not to scale. I'm not going to worry about that for now. 8, 6, and 35. That's what we started with. So we're saying in this case, this would be like 49.89. And this one would be 130.113. So in this case, it looks like no problem, right? If we had 180 minus 35 minus 49, this angle would be 95.113. And that's cool. How about this one? We'd have 180 minus 35 minus 130, and that would give us an angle of 14.89. And both of those seem fine, right? And now we just are left to solve for this last side. So let's do it. We can use the law of sines again. So, and let's see, they didn't give us the name of that side. So let's call it x. So sine of 35 divided by 6, we'll use this ratio, equals sine of 95.113 divided by x. And so that means that x is going to equal sine of 95.113 divided by sine of 35 times 6, right? If I, sorry, I'll show you my writing. Right, if I multiply by x, if I cross multiply and then divide by sine of 35, that's how I could think of it. So I'm going to put this in my calculator. So sine of 95 times 6 divided by sine of 35 gives me this side is equal to 10.42. And I can do something similar over here. Let's make it easier on ourselves and write it write this as 6 over sine of 35 equals x over sine of 14.89. Right, we can either put the signs on the bottom or the top of our ratios. So let's just do it that way so it makes it more straightforward. So 6 times sine of 14.89 divided by sine of 35. I get that x equals 2.69. And hopefully that matches what they get. So here's the situation. We've got two triangles. One where this side kind of swings in and one where it swings out. Okay, and this still fits all the criteria. They gave us this angle here. They gave us this side and they gave us this side. So this side could swing in or it could swing out. So that means we're going to have a short side and a big angle, or a long side and a small angle, which is kind of what we got, right? Big angle, small side, small angle, big side. And oh, this is the side. Yes, perfect. We match what they get. All right, here's what the triangles could actually look like. Here's our two sides. Here's our angle 130, 14.9, 2.7. So this triangle is this case, and this triangle is this case, 10.4, and our angle is 49.9. So in both cases, look, this is still 8, this is still 6, and that's 35, but our triangles look really different. Okay, that's what can happen when we have a side-side angle. So how do we know we have sides? So how do we know we might have, this is called the ambiguous case. How do we know what happens? We have side-side angle. So what do? We get our first beta, and then we find our second beta and try to make our two triangles. Okay, so let's do another example. How about this one? They give us side-side angle. We've got two sides and an angle not in between them, and we want to solve this triangle. Okay, so let's see, we'll use this ratio. So we'll say sine of 85 divided by 12 equals sine of beta divided by 9. Right? So we get that sine of beta equals 9 times sine of 85 divided by 12. I'm going to put this in our calculator. We get 9 times sine, I know you can't really see that very well. It's tricky with the lighting. Okay, 9 times sine of 85 divided by 12. So I get sine of beta equals 0.747, and I find the inverse sine of that, and I get beta 1 equals 48.34. And then I'll find beta 2 is going to be 180 minus that. 131.66. All right, so now I'll draw my two triangles. Alpha, this is 12. This would be 48.34. This is 85. This is 9. So again, I'm not drawing these to scale because, and in this case, this would be 131.66, and this is 85. Okay, now I want to find my third angle. So in this case, I'll just say 180 minus 85 minus 48.34. And I get 46.65. That looks cool. How about in this case? Let's see if I can move this over and leave my calculator there. Yes, okay, so I'll say 180 minus 85 minus 131. Do you see a problem? What's going to happen? Minus 36. This angle is minus 36. Is that possible? That is not possible. So this triangle, Doesn't happen. Okay, we only have, even though it's the ambiguous case, in this case, we've just got this one triangle to solve. Okay, so you know this will happen when you get a negative angle, right? You say, that second case actually can't happen. It's just this. This is our one triangle, and we can solve it. We've got three angles. We just need to find one more side. So let's use the law of sines again. Let's say 12 divided by sine of 85 equals, what are we calling this side? A? Yeah, equals A divided by sine of 46.65. So let's see, 12 times sine of 46.65 divided by sine of 85. I get that A equals 8.76. Do you believe it? Sure, that seems like a reasonable side there. Okay, so here we have a case where we have side-side angle, and we just get one triangle. All right, you probably can guess what's coming, but let's do another one. Let's try this one. Ooh, I showed you. Find all possible triangles if one side has length 4, so we have to draw this here. Let's say one side has length 4, opposite an angle of 50, and the second side has length 10. So let's just say that. Okay. All right, so let's call this side alpha, or this angle alpha. So we have a ratio. Let's find that angle. Sine of 50 divided by 4 equals sine of alpha divided by 10. Okay. I'll put this here, you can see it. So let's see, 10 times sine of 50. Who is it? 10 times sine of 50 divided by 4. So sine of alpha equals 1.92. Do you see a problem? Yes. Sine can only go from -1 to 1, right? If I put this in my calculator, in fact, I can just do that right now. Inverse sine of this is an error. Okay, we can't take, this doesn't exist. So this case, here's the situation. Here's what's happening. We have 10, we have 4, and there's 50. There's just no way for this to be long. This isn't long enough to connect with this other side. This triangle doesn't exist. Okay. So if we go back to our slideshow here, we've done this, right? We have no triangle. We had one triangle. We had two triangles. Right triangle is kind of like this. Oops. A right triangle is kind of a special case of one triangle, right? So we've had 0, 1, or 2 triangles. And you can't tell at the beginning. You can tell, I've got a side-side angle. This is the ambiguous case. I've got to be careful here, right? But you don't know at the beginning which case it's going to be until either you get, in this case, sine of something you can't take the angle of, or that doesn't exist. Sine of something is greater than 1. In this case, one of your triangles has a negative angle. Can't happen. Or this case where both triangles work out and you just solve them.